All right, chemistry, we are going to be in our notes on page 4 right now. So if you guys want to hop over to page 4, we're going to be towards the top of the page. I'll give you a second to make your way there. All right, so before we start talking about our topic, I want to do a little illustration. The weather's maybe starting to heat up, so maybe some of you guys are thinking, sweet, I'm going to go to the pool and, just get all the vitamin D and tan and just happiness, which is awesome. There's an interesting fact, though, about swimming pools, specifically public swimming pools, that may be a little alarming to you. In public swimming pools, there's a certain substance that if you were to isolate that substance and put it in one space, it would take up a volume about the size of one of the large trash cans, similar to what we see in the halls here at Ridgeline. Maybe take a second, think to yourself, what could that substance be that is in pretty much every swimming pool? And if we isolated it, it would take up this much space. I'm talking like Olympic-sized swimming pool, like a lap pool. So maybe think to yourself, if you said urine, you are correct. If you were to look at an average swimming pool and you were to isolate all the particles of mostly human urine, you would find a massive amount, which is pretty disgusting. Now, when you look at like a gallon, not a gallon, but a massive garbage can full of this stuff, you think that's disgusting. But if you actually look at the proportion for the entire pool, this visual right here shows that in a swimming pool, you're going to have most of it, the vast majority is just going to be the pool water and whatever other chemicals they have in there, and just a little tiny bit, just a little bit of the stuff in there is urine. So why are we talking about this? Well, I'm trying to think of a relevant way for you guys to remember parts per million. So this example shows very dilute concentration of urine in the pool, and parts per million, which we abbreviate as ppm, is a way to measure very dilute solutions. So we're not going to be using molarity, which we normally use for concentration measuring. We're using parts per million. I want you guys to write down the formula, although I'm not going to have you do any calculations with this. So in the formula box near the top of page 4, you can go ahead and write this. Parts per million is calculated by taking the grams of your solute. This is whatever you're dissolving, dividing it by the grams of your solution. So that's going to be like the whole item it's dissolved in. So this is like the pool volume. And then you're going to multiply it by 1,000,000. This fraction by itself is very, 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 very small number. So you multiply it by 1,000,000 to get the parts per million. So what does it mean? If I told you that something was 1 part per million, that would mean that there are 1 parts of solute for every 1,000,000 parts of that solution that we have. So you guys have this picture in your notes. It's not in color, so it might be a little bit tricky to see, but these syringes show different concentrations in parts per million. So the one up here, this is the most concentrated. This is showing what 10,000 parts per million represents. So if we had 1,000,000 parts of the solution in here, 10,000 of them would be whatever our solute is. We can go a little bit more dilute, right? 1,000 parts per million, 100 parts per million, 10 and 1. So like 10 parts per million, for example, would mean that if you had 1,000,000 parts, 1,000,000 particles of solution or grams of solution, 10 of those would be your solute. So incredibly dilute. We're going to use parts per million when we have incredibly small amounts of solute. So a lot of times we use these for toxins. Sometimes if you go to a certain area, maybe it's, well, I'll show you a couple examples, but certain areas have allowed substances. Like for example, you can actually be exposed to things like arsenic and chloroform in very small amounts and not get hurt because it's such a small amount. These are kind of some little bit disgusting, maybe disheartening facts. The FDA actually regulates allowed substances in our food. And so if you go and you buy tomato juice to make some kind of sauce or whatever, the FDA actually allows for up to 10 fly eggs or 1 maggot per 100 grams. And that is totally passable as allowed. Another one is, if you're going to get spices, the FDA has different regulations. If you have 50 grams of cinnamon or 25 grams of paprika, the FDA will allow for up to 10 rodent hairs. And I'm not sure how they come up with these numbers, but that's pretty specific. Like if you hit 11 rodent hairs, you got to throw it out, but 10 is the okay number. Cinnamon actually has insects and bugs in it, and you can have up to 400 insect fragments allowed in a 50-gram sample, which I'm not sure what unit insect fragments really represents, but that's that. Another one, mold, which this one we actually see quite a bit. Quite a bit of the fruit we eat and vegetables do have a little bit of mold in them. The FDA will allow for up to 14% per sample for certain jams and sauces. And it's crazy. Like, I mean, some of us eat mold for fun. Like if you ever eat blue cheese, you're just eating mold, but maybe in fruit, you don't want it as much. The FDA uses the term mammalian excreta to say rodent poop, which is allowed in certain spices. You can have trace amounts up to 9 milligrams per pound. So that's a very small amount. There's a pretty good chance in your life at some point you have eaten rat poo, and the FDA said it was okay. There's other applications of parts per million. In the drinking water that we have, most of us get our drinking water probably from the city, and they have to make sure and test it so that it's safe. One thing they test the drinking water for is chlorine. We can't have too much chlorine in the water, it makes us sick. They have to test it, and if there are more than 4 parts chlorine per million parts of the cup of water that we get, then that's bad. The max is 4. If you work construction or if you're into mining, there's going to be people who check the soil for certain chemicals that can harm us. One of those is arsenic. Arsenic gets into your DNA and causes all sorts of problems like cancer and death. The allowed amount of arsenic in a sample of soil is 0.39 parts per million. Very, very small. Arsenic is quite deadly in even small amounts. Another example is tuna fish. The substance that can get caught up in tuna fish and other marine animals is mercury. Mercury, if it gets in our bodies, is definitely not a good time. But you can have up to 0.32 parts per million of mercury, and you should be okay. So those are just some applications for parts per million. I'm not having you do calculations, but I want you to recognize that parts per million is important and that it's used for very small concentrations. And that's all I have for the lecture today.